Hey everyone, now we're on to question number 14 in the 2019 B test. The question reads, a ball is launched at speed v at angle theta above the horizontal toward a vertical wall a distance L away. So draw this out. You have a ball launched at this speed v at this angle theta, and then it reaches this horizontal wall a distance L away. Okay, it bounces elastically off the wall and falls back to its launch point. What is its initial speed? So we can imagine like the path might be hits like this and then follows the exact same path back and back to this launch point. And we're trying to find what v is in terms of LG and theta. Okay. This question actually has a lot of ways you can do it since this problem is so symmetric. The way that I'll do it though is based on the fact that since it's bouncing elastically, it's basically as if no energy is lost, so it's almost as if it travels and goes through the wall, and it's almost as if nothing happened to it, and then it traveled a distance, has a range of 2L, right? And you can see that these two situations are the same because it lands at the exact same point from the launch point, right? And yeah, and because it lands exactly back at the launch point, you know that it has to have hit the wall at the maximum height, right, of the trajectory. If it didn't hit the ball at the maximum height of the trajectory, then it would not land back at the original height. Like you can imagine that if the trajectory is supposed to be like this, but then the wall's right here, it'll bounce off like that, and then it won't land back in the original launch place. So we know that it has to have hit the wall at the exact top of the trajectory, right? So I didn't draw this very well, but you can imagine that this is actually the top of the trajectory right here, okay? So now, basically, what we're given is what you could do actually. Another way you could do this problem is given that it travels a distance L in order to reach its maximum height. What's this velocity in terms of this theta, right? There's a lot of ways you can do this. So actually, I'll do it by assuming that it goes an entire 2L distance, right? Assuming that basically it didn't hit a wall. And then what's this velocity required in order for it to go a distance of 2L? So we'll start off by looking at the change in y of this situation, which is equal to 0, right? Because it's starting and in the same y position. That's equal to negative 1/2 g t squared plus vy t, okay? So we can see that 2vy over g is equal to t. Just simplifying this equation down. Yeah, and vy, as we can see from trigonometry, vy is equal to v sine of theta. Right. So then we know that delta x, the range of the motion, which is equal to 2L, is equal to vx times this time right here, right? So that's equal to, and what is vx? Vx is just v cosine of theta, right? So I'm just going to change it all to v. So this is v cosine of theta, and then plug in t, 2, and then vy is v sine of theta over g, right? So that gives us 2L is equal to v squared, 2 times v squared, sine times cosine, sine theta, cosine theta, divided by g. Quick cancel this out, and now we can we can isolate v because the question's asking for what is the speed v. So then that's v is equal to, or v squared is equal to g times L divided by sine theta cosine theta. So that means v is equal to the square root of this. Actually, it's not one of these answer choices yet because we can simplify this down slightly by noticing that sine theta times cosine theta is the same as, if you remember your trig identities, the same as sine of 2 theta divided by 2, right? So that means that if we just plug this thing into here, then the 2 goes into the numerator, 2gl over sine of 2 theta, the square root of this is equal to v, which is this answer.